Hello everybody and welcome to this webinar brought to you today by SimLogic. The webinar today is going to focus on energy management and how to cut costs in 3 steps. Today's presenter is Fraser Thompson, an MES consultant with SimLogic. So I've just got a bit of housekeeping to go through first. If you'd like to ask a question, we do welcome questions from the audience and it does make the webinar more interactive. You will see a question panel on the right hand side of your screen if you'd just like to enter your questions there. And if we have time at the end of the webinar, we will get back to you with the answers. If not, we will email you the answers to your questions afterwards. For a copy of the presentation or for further information after the webinar is finished, please send an email to inquiries@simlogic.co.uk. So SimLogic, we were established in 1997. We're based in Saltaire, West Yorkshire. And we're one of the partners for the Parsec Automation company. We have MOM and MES solution, Traxys, and we're the integration partner for the UK and Ireland. Our goal is to deliver outstanding manufacturing improvement solutions which enable our customers to continue to be world-class performers. As I mentioned earlier, the presenter today is Fraser Thompson from SimLogic. He's got 8 years experience in MES in the UK manufacturing sector, and his specialities include OEE, SPC, EQMS and energy management. So without further ado, I'd like to pass over to Fraser.
Thank you very much, Emma, for the introduction, and welcome along everybody. So very briefly, I'll just cover off a little bit of the agenda for today's webinar, focusing on energy management. First thing we're going to look at is what kind of strategic objectives do manufacturers today have that might lead them towards seeking or looking to undertake some kind of initiative with regards to energy management. How we might make a case for that, so looking a little bit about the background on energy usage and future trends, what's going to go and happen in the future that we all need to be prepared for, the challenges that we face, particularly from a manufacturing sector environment with regards to energy, and finally, down to the good bit, is our kind of 3-step recommendations, or a 3-step process of recommendations to help you implement, improve your energy management systems, and ultimately add extra value to your bottom line. So we'll start off by looking at sort of strategic objectives. What are companies, manufacturing companies, trying to latch on to today to help them either jumpstart an energy management program or continue an energy management program that may have started maybe 1, 2, up to sort of 5 years ago. Now, many of you would be familiar with the word sustainability. Sustainability can mean lots of different things to different people. It's a bit of a buzzword that's floating around at the moment. Sustainability could mean, as we're talking about today, how energy efficient we are, what's our carbon footprint, and so on. But sustainability can also mean, are we being environmentally responsible? Are we looking at having a sustainable business through a sustainable supply chain? Are we looking after our suppliers and our customers? What are our emissions? What are our carbon footprints? Are we looking at zero to landfill type initiatives? So sustainability can kind of be wrapped up into any one of those things, but it all sort of comes down to profitability, responsibility, compliance, and public image. These are the things that we want to either improve or protect. So obviously profitability, if we can reduce our energy consumption or meet our sustainability goals, then we are hopefully going to be more profitable as an organization. We then get a feeling of responsibility to the environment, to the public. We're protecting the environment, we're reducing our carbon footprint. Everybody's health and safety is of the utmost importance. We're meeting emissions targets and regulations that are set by the government, and also we're portraying a very positive public image, outwardly facing public image, that we are serious about energy monitoring. we're serious about making improvements in our energy usage and being a sustainable organisation for not only today but also the future. So there's a little bit on the kind of things that might be driving us towards looking at energy management. What's the background? Well, I'm sure you're all aware of the various fluctuations that have happened in the energy market over the last sort of 5 to 10 years. There is always going to be a need for energy as far as we can tell currently, and the way that society, culture are all progressing, it can only lead one way, and that's into increased energy demands. We're all advancing technology. We're trying to move from manual-based processes to automated processes, looking at more modern equipment, machinery, robotics, and so on, all of which can place a high demand on energy. Now, not only electricity, but also compressed air, water, gas, and so on. So as far as we can see, there is going to be an increased demand in our time, and it will continue to increase over the next sort of 5, 10, 20 years, and so on. So where's it all heading? Well, by sort of 2040, some sort of wild predictions that are out there is we're going to see some population growth. That's pretty well understood, well believed. We believe there's going to be about another 2 billion people on the planet by 2040. We're probably going to see an increase in the global economy as different markets come on board. We're again expecting around 130% larger global economy by 2040. And all of that should potentially lead to about 56% growth in energy consumption from where we are currently in 2015. And again, this is all driven by the growth in technology, in automation, in infrastructure. So it's not something we need to just think about with today's or with a 2015 or a 2020 head-on. Any energy initiative or energy management initiative that we put in place today needs to also have one eye on the future. It's a great way to save costs and increase profits today, but we also want to protect profits for tomorrow. So we need to be thinking about the potential future impact. And again, cost and demand is only going one way, and that's up, and we all need to be prepared for that. So what types of fuel, what types of energy are we going to need? Well, there's a very quick estimate here from ExxonMobil. Again, looking at that sort of 2040 picture about where our energy demands are going to come from, we can see there the more traditional sort of fossil fuel energy sources, oil, gas, coal, are fairly stable. There's an increase, as you can see, the obvious increase in there is straight away in the electricity. All of the new technology, the advent of technology that we're looking at is basically going to increase our electricity demands. So it's not going to come from oil, gas and coal. We're going to need to be either more efficient or we're going to need to generate more electricity from renewable sources. So that's essentially a 90% increase in demand over the next sort of 25 years. Almost doubling of demand of electricity, which could to some be quite concerning. So how are we going to make a case for energy management or more effective energy management? The need for energy will always be increasing. It's going to be a taxing time demand on all of us. And if we want to be serious about energy conservation, then we need to look at exactly what we're using today and protect ourselves from this rise in costs or rise in demand in the future. Even the same amount of energy required today would cost us more potentially tomorrow. And you might currently be looking at ways towards buying more energy efficient equipment for your infrastructure. And again, that's one thing you can be looking at, but also we need to be looking at how we can do more with the infrastructure that we currently have. We need to be engaging more sustainable practices that are going to yield even more substantial savings year on year in the future. So it's very, very important to start, if not start now, to start thinking about it now, to start planning for the future now. So what are some of the top challenges that are faced within manufacturing when it comes to energy management? We'll just read down the list very quickly from the top, consider the top few on there. So energy metrics are not effectively measured, or disparate systems and data sources, no formal process for continuous improvement, a lack of visibility into performance. They can all almost be wrapped up into very sort of common technological reasons. The reasons that we don't have effective measuring is because we wait till the end of the quarter to get our electricity bill, and Bob in the maintenance department needs to walk around 5 electricity panels and take meter readings from individual meters and write it down on a piece of paper, and he only does that once a month or once a quarter. Again, you might have energy meter readings taken in that way. You might have gas meter readings taken in another. You may be getting a water bill and you're not quite sure how that's being metered. There are lots of different sources and different issues that you can come across, and all of them are kind of stumbling blocks or barriers to success that people are currently experiencing. So why aren't we effectively managing that today? Well, there are a number of reasons for it, and the bottom few reasons on that list, they kind of lead towards why perhaps we're struggling with the top few. So a lack of executive support, a lack of culture, a lack of collaboration across departments, no formal process for managing risk. Those kind of reasons are more cultural. They're less they're less dependent on technology. They're more about a culture of adoption and a culture of improvement and sustainability. So that's where kind of energy falls into this kind of continuous improvement culture. When we're talking about continuous improvement, we're not just talking about getting more out of the door with the same assets. We can also be talking about, again, conserving energy, saving energy, and reducing our energy bills, and so on. So we need to make sure that we're closing the loop with decisions and actions, so we're able to effectively measure, addressing the top challenges on there, but also we're able to effectively do something with the data when we measure it, and that would address the bottom few challenges. So on to our nice and simple 3-step plan to help you reduce or implement an effective energy management system. We believe, and we're very passionate about this, the first step is to adopt a lean, continuous improvement culture that's looking at reducing our manufacturing costs. It might be lean, it might be Six Sigma, it might be operational excellence. The names are endless, but it's very important to have that culture in there and take a leaf out of the book of those cultures. Take the tools, take the methodology that they teach us, and apply them to energy management. Again, think lean. Lean procedures shouldn't be restricted to purely maintaining or looking at wasted motion within our supply chain, looking at defects or waste in raw materials. Energy is a raw material. Quite often, it can be a large proportion of the costs, or the raw material costs of our production is the energy that we need to consume. If we're running a process where we have an oven or a freezer, for example, some things that are high energy demanding piece of equipment, then the energy could account for anywhere between sort of 15 and 50% of the overall production costs, which is very high. So it's very important that it's considered and it's given the same amount of respect, of impact, that all of the other raw materials that you would traditionally consider raw materials, and we look at the waste in the same way. So what kind of tools and methodology are available to us? And again, we can look at the lean toolbox in that case as well. But it's important that we use it when it's needed. We're not just using it for the sake of it. We're not just using it just on electricity, but we focus again on water, on steam. We look at the use on inefficient machines. We think about, for example, one of our customers recently was going through a value stream map exercise as part of their lean journey. And they decided they were going to apply that to energy management. So we're going to look at the energy consumed at each stage of the process and what potential energy wastage there was when machines were still running when not producing. Again, it's all very important things to consider and to think about when you're adopting these kinds of systems and practices. what's the impact of continuous improvement and lean? Well, the initial idea is that you want to do more with less, or more with the same. You want to reduce the manufacturing lead time throughout the value stream, and that will give you a number of added value benefits. So we should be able to reduce waste, we should be able to reduce the amount of raw materials that we're consuming, we should be able to produce the same amount of goods in less time with potentially less resources and labour. But importantly, as I've highlighted it there, one thing that's often overlooked is the energy needed to operate that equipment is also reduced. If you're currently running a 24/7 operation and you're producing 2 million units a week, and you're able to produce 2 million units, for example, in a 24/5 operation by being more lean, then instantly we've got an energy saving by not having the equipment running during those 2 weekend shifts, if we like, for example. So some companies are already seeing the benefits of that, but potentially not measuring it. So if you are already adopting continuous improvement, lean, Six Sigma kind of methodologies and seeing improvements, the likelihood is that someone somewhere down the line is seeing a reduction in their energy bills. And perhaps you're not attributing one to the other, whereas we absolutely should be. So it's important that we make sure that all of the slightly intangible benefits that we can gain from operational excellence activities are actually given the respect that they're due, essentially. It's often that energy management is something that's separate and not linked with operational excellence, but we need to make sure that it's definitely brought together and seen as one. So the diagram on the slide in front of you may look slightly familiar. This one's taken from the Energy Star guidelines, but for those of you that are familiar with DMAIC, again, it's very similar. Again, DMAIC being define, measure, analyze, improve, and control. The process here that's been recommended by the Energy Star guidelines, again, make a commitment, assess the performance, set your goals, create an action plan, implement the action plan, evaluate the progress, recognize achievements, and then reassess and continue the process as a continual process. So again, for those of you that are familiar with Six Sigma principles, that should all be fairly obvious to you. The one thing that I would like to stress in there is recognition. Again, recognition is not necessarily one of the areas that's included directly within DMAIC, but it's very important to give us that engagement and that buy-in from everybody that's involved in the process, is to recognise people's achievements. If we've come up with a plan of action, or let's start again. If we've made a commitment that we're going to reduce our energy consumption by 10% over the next 3 years, we're going to assess where we currently are and set ourselves some goals. We're going to create an action plan to get us towards that might contain a number of projects. We go through implementing that. It's important that if that's actually achieved, or if we achieve close to it or better than it, that the team that were involved are effectively recognised. Without that recognition, again, it could become just another fad that's given focus. The current management, they're very keen on energy, and then a new set of management comes in and their focus is more on the production output rather than the energy. So by giving it the recognition it deserves, again, we can add focus and make sure that it's something that's continued over time. And lean actually works. So this is maybe slightly contradictory to what we were saying earlier. But this chart on the page in front of you is showing the energy used by manufacturing industry in the UK, and it's showing a decline of about 23% from 1970 to 2010. And there might be a number of reasons for that. The reasons for that might be the equipment that we're producing is becoming more efficient. We're able to do more with less. And that's testament really to the fact that lean kind of works really. The implementation of lean thinking, lean cultures does actually have a benefit. And that's a trend that we need to see continuing. It's a trend that we can't afford to see plateau out and become level. It's something that we need to make sure is continually dropping to the lowest point that we can get it at. But interestingly, the output is increasing as energy is reducing. So that's a good success story in there. But it's important for us not to take our eye off the ball and make sure that we all do concentrate on making sure that trend over the next 10, 15 years follows a very similar pattern. So step 2, measure your energy usage and optimize equipment efficiency. This might sound fairly obvious to most of you, but perhaps it's not. How do we understand what it is we're going to be doing? We need to measure it. We need to measure where we are today. We need to measure the impact of the changes we put in place, whether they're positive or negative, and we need to do that in a way that is actionable. We need to have information that we can actually use. We don't need to wait till the end of the quarter to see an electricity bill and then think to ourselves, well, that's pretty high. What have we done over the last quarter to mean that our gas usage or our electricity usage was so high, when the real cause of that might have been 3 months ago? It's already passed us by, and it's been in that state for the last 3 months. So we need to make sure that we measure it, and we measure it in an appropriate fashion so that we can action the data that we're capturing. So first of all, let's consider where we're using energy. Let's consider that we put energy usage in context. So what are the energy costs for the current shift, the current day, the current month, the current work order that we're producing? What is the optimal cost of energy per unit of production? So if I have a production schedule with a target of 200,000 units for the evening shift, what's the optimal level of energy that I should be consuming for those 200,000 units? Do I know that? Well, I need to measure it to start with to see where we are. I need to benchmark, and I need to set ourselves some goals for improvements. What are the primary factors that impact the energy efficiency of facilities and assets? Is it a case that it all depends on the ambient temperature, and therefore we consume more energy in trying to keep the building cool during the summer than we do during the winter? Or how much energy, for example, is wasted during non-production periods? I can't tell you how many production facilities I've walked around that haven't been producing anything when conveyors have still been running and ticking along without any energy saving modes set in the equipment, just running away all the motors while we're not producing anything. What does it take to find the answers to these questions? How are we going to go about getting this information? What opportunities are out there for us, and how are we ever going to understand that if we can't actively measure it? And that's sometimes quite a barrier to people, but it's a technological barrier. I'm sure you're all familiar with smart meters now for your homes. Again, very similar technology exists from a manufacturing automation perspective. Energy metering devices, flow metering devices are all available now. They're all coming capable of communicating with other devices, thinking about the Internet of Things, and so on. So it's all possible, but we need to consider where we measure, when we measure, and what we're measuring to make sure that we capture the full production picture. And I'm sure, again, most of you have heard of this statement: you can't improve what you don't measure. There's a little quote there from a guy from the US Department of Energy. Unless the factory actively manages energy use and has a documented plan for doing so, their facilities are significantly less energy efficient than they could be. Without performance indicators that relate energy to consumption to production output, it's difficult to measure or document improvements in energy intensity. Never a truer word said. I'm sure, again, we've all been sat in production meetings and we've discussed opinionated information that's been gathered from people that's perhaps inaccurate, not very timely, and we've all spent more time discussing the inaccuracies in the data rather than what we're actually going to do about it. We need to make sure that what we measure is accurate, and therefore we can start making some improvements based upon that data. Benchmarking, again, very, very important again. So we need to set ourselves some benchmarks. How do we know if we're consuming too much energy with respect to production if we haven't set ourselves a benchmark or a baseline that we're going to work from? I'll step that back slightly again into energy and procurement, perhaps I should say, rather than just energy procurement, because it's kind of in two areas. You can procure your energy in different ways. You can buy in bulk in advance If you're aware there's going to be a high demand for gas over the next 12 months, then you can buy at today's rates your gas supply for the year and so on. But procurement can also have another impact on energy based on the raw materials that are produced. Again, you might be looking to save some raw materials costs by purchasing a slightly inferior raw material, but that slightly inferior raw material might cost you more to turn into a finished good. It might mean that you end up consuming more energy to effectively process that. A good example of which would be within, for example, the dairy industry. It might be that you are producing a slightly inferior you are purchasing a slightly inferior quality of milk, which has a higher water content, and therefore it's harder for you to process that into a good quality cheese. And you will consume more labour resources, more energy resources to make that production process happen. Whereas if you perhaps procured a slightly higher quality, more expensive raw material with a lower water content, your cheese creation process would be more energy efficient, more labour efficient, and so on. But also looking at our energy consumption. So what are our sources of data? Now, I like to break it down into a few areas. Water is one. Obviously, water is a resource that we can consume, a utility that we can consume. Gas and electricity are the other two obvious sources. But there may be two others that would be worthwhile measuring. The first one being, are we using steam? Are we having to generate steam, or are we buying steam in for our production process? There can be quite a high cost to that. And secondly is compressed air. Compressed air is one of the highest consumers of electricity within a manufacturing process. So again, maybe we want to measure compressed air separately from general electricity usage. Make sure that we're collecting all this and it's actionable, so it's real time. It's not from a trend from 3 years ago that we're making business decisions or what happened last week. It's more about what's happening today, so we can make some good business decisions based on accurate business data. Tools that deliver results. Again, I'm sure you're all aware that you can manually get readings and records, but we need to move towards being a little bit smarter with it now, going through manual, through calculated to metered to now into smart metering again. And I've already touched on that very slightly with respect to, for example, your home energy usage. So how do we do that? How are we going to go about looking at capturing all of this information and pulling it all together, giving us the ability to start making some improvements? And using our Traxis solution, we have the ability to capture all of these various different elements. And again, they're listed down the left-hand side there. So electricity, steam, gas, water, and compressed air. So I've included the common 3 and the less common 2 within there. So using our software solution, we're able to capture, record all of those data points, but importantly, at the bottom of the diagram, there is linking to other systems and applications. So let's link it to the plant 4. Let's link it to our production schedule. Let's link it into our labor utilization tools so that we know how many people are on the line. If the line is scheduled to run, for example, if we've got a gap in production where we're doing a changeover and there's a 3-hour changeover, does it make economical sense to us to shut the oven down during those 3 hours so that we're not consuming the gas? We're not having to air condition the rest of the building because of the residual heat of the oven during that time period to such an extent, because we've got the ability to turn it off while we're not producing. So it's by adding that context, by adding other data sources into our energy metering, that we're able to make better, more effective business decisions. And the tool will also give us the ability to look at the real time and also analyze it against the historical. So we can base our benchmarks from historical data, and we can obviously improve those benchmarks over time. But then we need to be looking at real-time interactions to say why, for example, we're consuming more electricity per ton of product today than we were tomorrow. Why is that? What are the other affecting factors? Then you can build that into a complete continuous improvement culture and a continuous improvement team that might want to use the data, plan the preventative maintenance, the schedule, all around this information, which should include energy consumption. Step 3, fairly obvious, but believe me, very often the most missed step of the 3 steps. So we've seen people come up with a plan, then implement something to improve the plan, and that's it. We never take that last step to make any physical improvements in what we're doing. Many continuous improvements focus on reports instead of what they should be doing with them. It's not all about reports. I can't stress that enough. This should not just be a tick in the box. It should not be the case that there is a requirement to record and report on energy, and then there's a tick in the box. Yep, I report on energy. We have accurate energy reports, but nobody is doing anything with the data. It's an absolute travesty. I've seen specifications for new equipment. We're going to buy some new capital equipment. It must be provided with an electricity meter. It's part of the specifications, and that electricity meter should be able to be connected to the Ethernet, the industrial Ethernet, and we should be able to get the data from it. Great. There's a tick in the box for somebody there. What are you actually going to do with that data? What, apart from having that meter in place, what information does that meter need to provide? Does it need to provide your kilowatt hours as a pulse? Does it need to provide your average current usage over the course of the day? Does it need to include some kind of power factor correction? What information do you physically need from that energy meter to get benefit from it, to add value, to start saving energy? Is it meaningful? Can you really do anything with it? Or are you just providing a report for a report's sake? The most important thing, if you take anything away from today, please take this away. What you should be using reports to do, obviously, is to gain insights into your energy consumptions, and you should be doing that with respect to certain things, with respect to the areas, the factory, the assets that you're using on, what products you're producing, what period of the day you are producing it in. You should be analysing the cost versus the demand, any maintenance activities that are going on, and looking for patterns in energy consumption. And by using the 2 of the above there, you can then drive this measurable improvement. It might be that this indicates that while your operators go for a lunch break, you're not producing any finished goods, but all the equipment again is left running. Is an indication that we need to link our energy consumption with our production plan. And by having all 3 pieces of the puzzle together, we can make an educated decision to turn the power off on those particular pieces of equipment. And again, we can also look at how we optimize our schedule with respect to energy usage. So do we produce, for example, our more or our higher energy consuming products at a time in the day when the energy costs us less, for example? Again, another idea or an advantage that you can have by looking at our energy usage in context. So as an example of putting the information to good use, let's look at retiring an asset. It's very, very common, something people do a lot of. The first thing I'm sure that most of you will be looking at is replacing the existing assets with a more energy efficient model, and that's great. You can definitely do that. It's definitely going to be a higher capital cost for you to do that. You might have a long lead time. You might be waiting months to years. You're going to disrupt operations in terms of downtime. You're going to need to schedule that in with production planning. You're going to need to build stock. And when you look at return on your investment, you may be looking at a very long time span. Whereas if you're able to stick with your existing assets and really squeeze every last drop out of what you can until the point when you definitely do need to retire that asset, you can often leverage far greater savings or production improvements than you can through building in through purchase or capital purchase of new assets. The time that it would take to implement those changes can often be vastly reduced from the time it would take to deliver a new piece of equipment. And you can start getting in the cost savings almost immediately. It's going to be a very low capital cost for that kind of initiative. So again, all this is kind of driving us to making good business decisions based on good data, really. And then I thought I would baffle you with a whole set of screenshots of the things that it is possible to do once you've got all the right data in the right area. So, for example, up on the top left-hand side there, we can see the example whereby production line has gone for a shutdown at lunchtime, but 3 out of the 4 pieces of equipment on our line have been left in a running state, whereas 1 has been turned off. There's opportunity in there, obviously, to save energy. We can look at our production versus the cost of energy. We can look at, again, our sort of value stream map again, example down in the lower right-hand corner there as well. So one of the important facts about having actionable intelligence, and this is quite a good one, is to understand what it is that you're looking at. What's the impact of production and workflow problems? What are the factors that adversely affect energy usage? What's the cost of energy usage per production unit? That's one of the key metrics I think we could take away from today. And if we look at the chart over on the right-hand side, we've got a quick scatter chart and a trend line for energy or our power consumption kilowatt per hour versus our production. It might be per ton, or in this case, it's tablets per hour. And we can use that kind of historical data to set ourselves a benchmark. So if I know, for example, that tomorrow I'm expecting to produce around 300,000 units, I would be expecting to consume somewhere between 205 and 217 kilowatts per hour. And we can set that as a benchmark. So straight away, if I'm quarter of the way through my production run and I am consuming in the region of sort of up end of 200 plus kilowatt hours, I can start to trigger notifications, emails, alerts as to the fact that we are over consuming electricity for the volume of production that's currently ongoing. And that might point us in various different directions. It might point us to a compressed air unit that's feeding the line with compressed air. There's a leak in the pipework, so it's again, it's an instant trigger. It's having the data in real time to enable you to do something about it in the there and then, really. So very finally, I've got a few references of companies that we've worked for and with along the lines of continuous improvement using the Traxys tool to help them drive their continuous improvement culture. Again, more information on request should you need it. But very finally, I think I would just put a wrapper to it and call it a holistic approach to energy management and summarize quickly our 3 steps. The first of which is think lean. Think about your continuous improvement, operational excellence, define yourself achievable goals and dedicate the appropriate resources to be able to work towards those goals. And implement best practices to drive cultural change. You don't need to make these things up from the start. You don't need to reinvent these processes. They're out there, they exist. You can learn from the people who have implemented them in the past and the industry best standards, if you like. Put in place tools to support your CI efforts. Again, measure. What gets measured gets done. And finally, take the action and make sure you do. Analyze, report, and manage energy uses. Make sure it's not just a tick in the box. And achieve a 0 energy cost increase or overall reduction. So that brings us to the end of the webinar.
Thank you, Fraser, for that presentation. It was very interesting, and I'm sure you'll agree it's very thought-provoking as well. Just to remind you, if you'd like to ask a question, if you use the questions panel on the right-hand side of your screen, we'll see if we can get to them. But if not, we will email you the answers to any questions you might have. If you'd like any further information on SimLogic, our software or services, you can visit our website, www.simlogic.co.uk. I'll just give you a moment to put in any questions you might have. Okay, we do have a question that's just come in. What special KPIs would you use, Fraser?
Okay, I think if we were going to take one KPI that we could definitely measure or make use of, it would be our energy consumption with respect to our production volume, as we saw on the slide a couple of slides ago. Try not to overcomplicate the number and variety of KPIs that you are using. Again, the more there are, the more that sometimes they can conflict with each other, and that's not going to help anybody. So let's keep it to a minimal set and make sure everybody understands that that's the set that we're going to be using. But if there was one key KPI that I would be looking to take away, it would be the consumption of energy versus production of our finished goods. That's definitely a very powerful indicator to where real-time opportunities to reduce our energy consumption can be gained.
Okay, we haven't had any more questions in yet. If you do think of any questions once we say goodbye today, you can email your questions to enquiries@simlogic.co.uk. So I think all that's left for us to say is thank you very much for joining us, and we hope you have an enjoyable rest of the week. Thank you.